This video marks the start of our discussion on factoring. And factoring is probably one of the most important concepts we're going to be doing this semester because it really has a lot of uses. It's a good thing to be able to manipulate equations and make them look simpler. So first thing I want to do is actually explain what factoring even means. So I have a problem on here that you guys have seen a while back. This is just a simple distributing problem if you want to simplify. So if the instruction said simplify, you would distribute and you'd get 20x minus 12. Both of these things, the black part and the red part, mean the same thing. It's really like, usually we've been like, oh, the red's better, we've used this, but there's nothing that says we always want this kind of thing simplified. Maybe we want to have it like this, and you'll see why as we move along. But my question in this video is, how do I get from the red back to the black? How do you go in reverse from distributing? So when I think of the GCF method, I'm thinking about reverse distributing. So when you distribute, you basically multiply a number on the outside into the problem. Same number gets multiplied against each parts. So what I'm going to think about right here is what number goes into both parts. What could I have already multiplied in? And on this problem, if you think about the biggest thing you can, the GCF that goes into both parts, the biggest number that goes into 12 and 20 is going to be a 4. So I can take a 4 out of each of these terms. So what I'm going to do here is put my 4, and then I'm going to put parentheses here, and I'm going to write what's left over. So if you picture, if I had multiplied in a 4, I want to do 4 times what gets me to 20x. Another way of thinking about it, we're going to do 20x divided by 4, and that is going to be a 5x. Negative 12 divided by 4 is going to be a negative 3. And if I distribute back in, you can see that you do get this answer, and it matches what's over here. So our basic strategy on this problem is going to be to think of the biggest thing that goes into each term, and you're going to pull it out by dividing. So we practiced how to find a GCF. Now that you know how to actually find one, we're going to look for it, pull it out, and divide the inside to see what's left over. So again, I looked at these two parts. I said, okay, 4 goes into both of these. Put that on the outside of the parentheses, and I divided by the number on the outside to get this guy in here. This is a topic that you're just going to have to see some examples to get used to. So I have those examples. I have 6 problems I want to walk through with you guys here, all doing the same sort of thing. So on my first problem right here, I need to figure out something that goes into 24 and 30. So if you think about different numbers that go into 24 and 30, you might say, okay, 2 works. So I'm going to write this down here, but don't copy this down just yet. If I take out a 2, I'm going to have negative 12x plus 15. Which isn't wrong, but there's still something else that goes into 12 and 15. You would have to take a 3 out again. So what I would do then is I would do 2, and then I have to take out a 3 as well. So I'd do 2 times 2, I'd get a 6, and then I'd get my answer like that if I were to do that. Not really ideal to have to do that multiple times. So when you look for these two pieces here, you try to take out the biggest number you can. So if I'm running through possibilities here for my GCF, I see that 6 goes into both of these, and 6 is the biggest thing. If I go any bigger than that, like 8 doesn't go into 30, 12 doesn't go into 30, 15 doesn't go into 24, there's nothing else bigger than 6 that works. And I am going to take out a negative 6 on this one. If you're trying to choose if you take out a negative or a positive, it doesn't terribly matter. Like you're not like the other way would be wrong, but I tend to listen to the bigger variable. So my variable on this one, what I mean by bigger variable is the one with the bigger exponents. So my variable was right here, and that guy was negative, so I took out a negative 6. If this had been a positive 24, and this had been a minus 3, I would have taken out a positive 6. So once you decide on what you're taking out, you divide by the number on the outside to see what's left. Negative 24x divided by 6 is going to be positive 4x. And positive 30 divided by 6 is going to be a minus 5. So this is my factored answer. On my next problem here, again, I'm looking at what goes into both parts, what goes into 63x and negative 9. And after thinking about the possibilities, it turns out that 9 goes into both of these. 63x divided by 9 is going to be a 7x. Negative 9 divided by 9 is going to be a negative 1. So So I'm going to put minus 1 right here. You can always check your answers, because if you distribute, you should get back to where you started. If I distribute this, I'm going to get that answer. I'm in good shape. That's my factored answer. On my next one here, I'm going to look at this, and I look at my 14 and my 15. If you think about numbers that go into 14, I have 1, 2, 7, and 14. That's really it. None of those numbers, except for 1, goes into 15. So there is no number. Pulling out a 1 does nothing, because when you divide by 1, nothing changes. So that's not really helpful for me. But on this one, it turns out that there is an x in both of these. There's 2 x's on this guy. There's 1 x in this guy. They have an x in common. So I'm going to pull out an x. And you can write a 1x if you want to. You don't have to. If I take an x out of this, 14x squared divided by 1x, I'm going to get 14. And there's only going to be 1x left over because I took one of them out. On the second part here, 15x, and I took out one of the x's, I'm going to have just a 15 left over. So this is my factored form. Same sort of idea in this next one here. I have negative 6 and 2. I'm going to deal with my numbers first. So negative 6 and 2, it turns out that 2 goes into both of those. And since my variable with the bigger exponents is a negative, I'm going to take out a negative 2. So I'm going to take out a negative 2. If I look at my variables, though, I can also take out some x's. I have 3 x's over here. I have 2 over here. They have 2 of them in common that I can take out. I can't take out 3 because there's not enough over here. But I can take 2 of those x's from each of them and put them on the outside. Then, to see what I'm left over with, negative 6 divided by negative 2 is 3. X to the third divided by x squared is just x. There's 1x left over. And on the second part, 2 divided by negative 2 is negative 1. I took out both my x's. That problem is done. Final 2 examples. When you have more than 2 terms, you have to make sure it goes into every single part. And once you do that, it's really the same sort of problem. So I need to decide in this one what goes into all 3 of those parts. So I always like to do the number first. And for my number on this one, I have negative 8, I have a 32, I have a 12. Run through the possibilities and see what works here. Nothing bigger than 8 is going to work because then it wouldn't go into this piece. So I'm going to check 8. 8 goes into 32, which is good. It doesn't go into 12. It ends up being a 4 in this one. 4 goes into all those. Since this guy is negative, I'm going to take out a negative 4. And if I look at my variables now, x squared, x, nothing. I can't take out any x's because this guy doesn't have any. So I have to just leave it as is, and I'm going to divide everything by that negative 4. So this guy divided by negative 4 is going to be 2x squared. This guy will be minus 8x. Followed by a plus 3. And again, if you're not sure if you did it right, distribute it back in and make sure you get the right answer. Final problem of the video. Taking my number first, I have a 5 that goes into all of these. With my m's, I have 4 m's over here, 3 over here, and this one kind of faded, but that should be a 6 over there. 3 of them are all I can take out. I can't take any more than that because this guy wouldn't have enough. So I'm going to take 3 of my m's out. And I have 3 n's, 1 n, 2 n's. I can only take out 1, smallest one right there. And now I just write what's left over. 30 divided by 5 is going to be a 6. M took out 3 of them. I have 1 m left over. I took out 1 of the n's. I have 2 left over. Negative 20 divided by 5 is minus 4. Took out all the m's and all the n's, so there's nothing else there. And finally, a plus 3m to the third n. So this is factoring in with the GCF method, and I have a feeling this is something we're definitely going to have to practice in class. So don't worry if it's not 100% right now, but hopefully the process is starting to become clear.